So for inverse trig function, what it means is that if it says inverse sine, the definition is if angle or if theta is an acute angle and the sine of theta is x, then the inverse sine of x is the measure of angle theta. So ultimately it means if sine theta equals x, then sine inverse or inverse sine of x equals to theta, or also known as arc sine x equals to theta. You would use the inverse sine function when you have the ratio and you're looking for the angle measurement. So unlike finding missing side lengths, here you're finding missing angle lengths or angle measurements. So found the definition, ultimately inverse sine is just basically if sine theta equals to x, then sine inverse or inverse sine x equals to theta, or also known as arc sine x equals to theta. So same can be followed. Inverse cosine, if cosine theta equals to x, then cosine inverse x equals to theta, or inverse cosine of x equals to theta, or arc cosine of x equals to theta. Same for inverse tangent. If tangent theta equals to x, then tangent inverse of x equals to theta, or inverse tangent of x equals to theta, also known as arc tan of x equals to theta. So when you're using inverse sine, inverse cosine, inverse tangent, you basically find these three definitions. And the same would apply to the reciprocal functions. So here on a calculator, if you go to calculate, and then let me clear this up. Now here you would go to trig, the bottom or the inverse trig function. So you see here is inverse sine or arc sine, inverse cosine or arc cosine, inverse tangent or arc tangent, inverse cosecant or arc cosecant, inverse secant or arc secant, and then inverse cotangent or arc cotangent. So you would use these 6 functions depending on the triangle, depending on the problem, in order to find your missing angle measurements. So again, you would just follow these 3 definitions for inverse sine, cosine, and tangent, and the same would apply to your reciprocal functions.